For most of human history, we imagined our solar system as an island, isolated in the vast darkness between stars. Tonight, we'll discover why a visitor from beyond, a comet called 3I Atlas, is quietly rewriting that story, revealing connections we never knew existed. Welcome to Get Sleepy Science. I'm so glad you found your way here tonight. Wherever you are right now, perhaps wrapped in blankets, watching shadows shift across your ceiling, allow yourself to settle into this shared moment of wonder. We'll explore 100 gentle truths about how one small object from another star system is changing our understanding of space itself. From old assumptions about isolation and emptiness, to new evidence of connection and exchange, to what this means about our place in the cosmic web. A journey from separation to belonging. A gentle like and subscribe helps fellow science lovers find their way to these calming stories that end the day with wonder. It takes just a moment, but it means the universe to us. When science meets peaceful sleep, minds find rest they've been searching for, one sleepy soul at a time. For now, just let your shoulders soften. Let your breathing fall into its own rhythm. There's nothing you need to remember, nothing you need to solve. Just drift through this story of discovery, letting facts become whispers, whispers become silence. Close your eyes and take a deep breath. You're lying in a small spacecraft, drifting gently through the endless night sky, moving without boundaries, without destination, only the light of distant stars and absolute silence. Let go of all limits. Let your mind drift through the vastness of space. For centuries, we understood space in a particular way. Our solar system seemed like an isolated island in a cosmic ocean, separated from other star systems by distances so vast that nothing could cross them. The planets orbit our sun in their eternal loops. Comets return from the Oort cloud on predictable schedules, and everything we observe belongs to our own gravitational family. Other star systems existed, yes, but over there, across gulfs measured in light years, two separate worlds that never touched, never exchanged, never influenced each other. This was the model we built, the understanding we taught, the picture we held in our collective imagination. Our solar system was ours alone, a closed system, an island in the dark. Then, on July 1st, 2025, something changed. A telescope in Chile detected a faint point of light moving against the background stars. At first, it seemed like just another asteroid or comet from our solar system's outer reaches. But as astronomers calculated its trajectory over the following hours and days, they realized something extraordinary. This object wasn't following an elliptical orbit around our sunday. It was following a hyperbolic path, an open trajectory that would never loop back. The numbers told an unmistakable story. This visitor came from outside our solar system entirely. They named it 3I Atlas, the third confirmed interstellar object ever observed. And with its arrival, our understanding of space itself began to shift. Could one small object really change how we understand space? That's the question scientists began asking immediately, because 3I Atlas wasn't just unusual, it was revolutionary evidence. Before 2017, interstellar objects were purely theoretical. Scientists suspected they existed, wandering between stars after being ejected from their home systems, but no one had actually seen one. Then Oumuamua appeared, the first confirmed visitor. 2 years later came Borisov, the second. Now, 3I Atlas is the third. 3 confirmed visitors in just 8 years. What seemed impossible is becoming routine. What seemed like isolation is revealing itself as connection. The old model, solar systems as separate islands, is starting to look incomplete. Perhaps space is something else entirely. Perhaps boundaries we assumed were absolute are actually permeable, crossed regularly by wanderers carrying news from distant shores. The first clue that 3I Atlas represents something fundamentally different is its speed. When it entered our solar system, it was traveling at 58 kilometers per second. Relative to the Sunday, that's about 130,000 miles per hour, or roughly 36 miles every single second. For comparison, Oumuamua entered at 26 kilometers per second and Borisov at 32. 3I Atlas is moving nearly twice as fast as the first interstellar visitor. This isn't a minor variation, it's a significant difference that tells us something profound. These objects aren't just rare stragglers accidentally ejected into space. They represent a spectrum, a population, a diverse community of wanderers with different origins, different histories, different energies. Space isn't empty between stars. It's filled with travelers moving at different speeds, carrying different stories. The orbital eccentricity of 3I Atlas 6.139 is the highest ever measured for any natural object observed in our solar system. Eccentricity is a number that describes the shape of an orbit. A perfect circle has eccentricity 0. Earth's slightly elliptical orbit has eccentricity about 0.017. Anything above 1 indicates a hyperbolic trajectory that will never return. But 6.139? That's not just hyperbolic. It's extraordinarily so. The path of 3I Atlas through our solar system is almost a straight line, barely deflected by the sun's gravity. This trajectory tells us the comet was moving with such momentum that our sun's gravity only gently guided its path, like a soft hand barely touching a passing traveler. Scientists estimate that 3I Atlas is approximately 4.6 billion years old, making it roughly the same age as our entire solar system. But unlike objects born in our system, this comet originated elsewhere, in a planetary system that formed when our own was just beginning. By tracing its trajectory backward through the galaxy, astronomers determined that it likely came from the thick disk of the Milky Way, a region populated by older, metal-poor stars formed in earlier epochs of galactic history. This means 3I Atlas has been wandering through interstellar space for potentially billions of years, crossing light years of emptiness while our Earth cooled, life evolved, and civilizations rose and fell. It's an elder, carrying chemistry from an ancient era of the galaxy's youth. The direction from which 3I Atlas approached reveals its deep connection to our galaxy's structure. When astronomers traced its path backward, they found it came from the direction of Sagittarius, near the galactic center, where hundreds of billions of stars orbit in dense spirals. This isn't random. The thick disk, where 3I Atlas likely originated, formed early in the Milky Way's history through different processes than the thin disk where our sun resides. Stars in the thick disk tend to have different chemical compositions, reflecting the galaxy's earlier state. If 3I Atlas formed in a planetary system around such a star, it might carry a chemical fingerprint of that different time and place. Each interstellar visitor is potentially a sample from a different epoch of galactic evolution, a messenger from when the Milky Way was younger. Determining the size of 3I Atlas has proven challenging, but observations from the Hubble Space Telescope suggest its nucleus is somewhere between 1,440 feet and 3.5 miles in diameter. If it's on the larger end of that estimate, it would be significantly bigger than the previous interstellar visitors. Oumuamua was estimated at only about 300 feet across, and Borisov less than half a mile. A 3-mile wide chunk of ice and rock from another star system, older than Earth, moving at speeds that dwarf anything native to our solar system, This is not a trivial object. It's substantial, ancient, and carrying potentially vast amounts of pristine material from another planetary system's formation. A cosmic time capsule, largely intact. Unlike Oumuamua, which showed no clear signs of cometary activity, 3I Atlas is unmistakably active. As it approached the Sun and warmed, frozen materials on its surface began to sublimate, releasing gas and dust that formed a visible coma roughly 26,400 kilometers across, wider than Earth's diameter. This coma has a reddish color, indicating the presence of organic compounds or certain minerals. Observations throughout July 2025 showed the coma becoming progressively redder, suggesting that material from deeper within the nucleus was being exposed as surface layers sublimated away. This activity tells us that 3I Atlas is not a dead rock, but a dynamic object responding to our Sun's warmth, revealing its composition layer by layer as it passes through. So here's the first answer to our question. Yes, 3I Atlas is already changing how we understand space. The old model of solar systems as separate islands is giving way to a new understanding of gentle connection. These interstellar objects are not rare anomalies, but regular travelers. Current models suggest there could be hundreds to thousands of interstellar objects within Neptune's orbit at any given time, though most remain too faint for our current telescopes to detect. But they're there, drifting through our neighborhood, some moving fast, some slow, some ancient, some relatively young, some rocky, some icy. A constant traffic of material flowing between star systems, crossing the supposed barriers, connecting planetary systems across light years. The galaxy is not a collection of isolated islands. It's an interconnected web, and we're just beginning to see the threads. Spectroscopic observations of 3I Atlas have revealed something fascinating about its composition. Astronomers detected carbon dioxide gas in its coma, similar to what's found in solar system comets. But they also found nickel, which is less common in our comets. These chemical signatures suggest that while interstellar objects may share some similarities with our own comets, they also carry differences, reflecting their foreign origins. Different star systems may have had different abundances of elements in their planet-forming disks, different temperatures, different pressures, different prime scales of formation. 3I Atlas is showing us that planetary chemistry varies across the galaxy, not drastically, but subtly, enough to be detectable, enough to tell us that other star systems are both familiar and foreign, like distant cousins who share some features but not others. The discovery of 3I Atlas wasn't made by a single telescope but confirmed by a global network. Within hours of the initial detection, telescopes around the world turned their attention skyward. By the time the Minor Planet Center officially announced the discovery on July 2nd, they had collected 122 observations from 31 different observatories. Professional facilities and amateur astronomers alike contributed data. This wasn't speculation or error. It was robust, verified reality. Multiple independent observers, using different instruments, all seeing the same thing, an object from beyond our solar system, passing through our neighborhood. The convergence of evidence from many sources removes doubt. Interstellar visitors are real, observable, and increasingly well documented. The phenomenon is established beyond question. Multiple NASA spacecraft have observed 3I Atlas, offering perspectives impossible from Earth. In October 2025, the Mars Reconnaissance Orbiter captured images from Mars orbit, getting about 10 times closer than Earth-based telescopes could. NASA's MAVEN spacecraft, also orbiting Mars, studied the comet with its instruments. The Lucy and Psyche spacecraft, en route to study asteroids, turned their cameras toward 3 Atlas in September. Even solar observation missions like Stereo joined the effort. This unprecedented coordination across the space science community demonstrates how seriously scientists take these opportunities. Each spacecraft added a piece to the puzzle, viewing the comet from different angles, with different instruments, building a three-dimensional understanding that no single vantage point could provide. Collective observation, revealing collective truth. Unlike Oumuamua, which was discovered only after it had already passed closest to the Sun, 3I Atlas was found when it was still beyond Jupiter's orbit, several months before perihelion. This early detection has been transformative for science. It allowed astronomers to watch the comet wake up as it approached the Sun, to observe how its activity increased, to measure changes in its composition and behavior over time. Early detection means comprehensive data. It means planning instead of scrambling, coordination instead of chaos, understanding instead of speculation. With each interstellar visitor, we're getting better at finding them earlier, which means we learn more. The detection rate is improving, the quality of data is increasing, our understanding is accelerating. With 3 confirmed interstellar objects now observed, patterns are beginning to emerge. Oumuamua showed no activity and appeared asteroid-like. Borisov was clearly a comet with a coma and tail. 3I Atlas is also clearly cometary. 2 out of 3 are icy bodies that respond to solar heating. This ratio suggests that interstellar space might be filled more with comets than asteroids, or at least that icy bodies are easier to detect because they become active and brighten as they approach stars. The diversity among just 3 objects, different speeds, different sizes, different levels of activity, hints at the vast diversity that must exist in the population we haven't yet detected. Each new discovery refines our statistical understanding of what's out there, wandering between stars. The Atlas telescope system that discovered 3I Atlas was designed primarily for planetary defense, scanning the sky each night to detect asteroids that might threaten Earth. Finding interstellar objects is essentially a byproduct of this constant vigilance, but it's a valuable one. As detection systems improve, as more telescopes join the search, as algorithms get better at identifying unusual motion, the discovery rate will increase. The Vera C. Rubin Observatory, now beginning operations, is expected to detect dozens of interstellar objects each year, with its unprecedented sky survey capabilities. What seems rare now will soon seem common. The invisible traffic of interstellar space is becoming visible. The true scale of connection is being revealed. The fact that 3I Atlas was discovered at all is partly a matter of timing. A few years earlier, before Atlas was operational, it might have passed through unnoticed. A few decades earlier, definitely unnoticed. We're living in the first era of human history, when we have the technology to detect these visitors and the knowledge to understand what they mean. This timing isn't just lucky. It's the result of decades of investment in astronomy, in detector technology, in computational power, in global coordination. We're reaping the harvest of centuries of scientific progress, and that progress is accelerating. Every year, our ability to see and understand the cosmos improves. Every year, more of the invisible becomes visible. Public interest in 3I Atlas has been significant, with news coverage and online discussions following its discovery and observations. This widespread attention reflects something important. People intuitively grasp that interstellar visitors matter. They represent tangible evidence that we're part of something larger. These aren't abstract concepts or mathematical models. They're actual physical objects we can photograph, study, touch with light from our telescopes. This tangibility makes the connection real, in a way that theory never could. Every person who reads about 3I Atlas, who looks up at the night sky and thinks about this ancient wanderer passing through, is participating in a collective shift of understanding. We're not isolated. We never were. We're just now seeing the evidence clearly. Every interstellar object raises the same question. How did it escape its home system? The process isn't random. Current models suggest that when giant planets form and migrate inward through young planetary systems, they gravitationally scatter smaller bodies. Some of these scattered objects gain enough velocity to escape entirely, becoming interstellar wanderers. This process appears to be universal, happening in planetary systems across the galaxy, which means every planetary system is both producing and potentially receiving interstellar objects. We eject material that ends up elsewhere. They eject material that ends up here. It's a galactic exchange program, operating on timescales of millions and billions of years. Each ejection event is energetic and dynamic, but the overall pattern is one of sharing, of distribution, of material spreading throughout the galaxy. When an object like 3I Atlas is ejected from its home system, it carries that system's chemistry with it. The ratio of carbon to nitrogen, the abundance of water versus methane, the presence of organic compounds, all these reflect conditions in the protoplanetary disk where it formed. By studying interstellar objects' compositions, we're essentially sampling other planetary systems without having to travel there. Each visitor is a free delivery of information about conditions elsewhere in the galaxy. Different stars, different disks, different chemistries, all arriving at our doorstep to be analyzed. The galaxy is running a natural experiment in comparative planetology, and interstellar objects are the data points. We just need to collect and interpret them. The detection of water vapor and organic compounds in interstellar comets like Borisov and 3I Atlas has profound implications. These are the ingredients necessary for life as we know it. If interstellar comets regularly carry water and organics between star systems, they might distribute life's building blocks throughout the galaxy. Some theories suggest that impacts from comets delivered much of Earth's water and possibly even organic molecules that contributed to the origin of life. If that process works here, it could work elsewhere. And if interstellar comets spread these materials across the galaxy, then the ingredients for life might be more evenly distributed than we thought. Connections between star systems aren't just physical, they might be biological. Life's precursors might travel on these ancient wanderers. When we step back and view our galaxy as a whole, 3I Atlas's journey makes more sense. The Milky Way contains roughly 200 billion stars, many with planetary systems. Over billions of years, those systems have ejected countless objects through the processes of planet formation and orbital evolution. All those ejected objects become the interstellar population, drifting through the space between stars, occasionally passing through other star systems. From this perspective, our solar system isn't receiving rare visitors, we're simply in the flow. The galaxy is filled with this traffic. We're part of a vast, ancient circulation of material. Some of it formed with us, around our sunday. Much more of it formed elsewhere, around other stars, now mixing throughout the galactic disk. One fascinating aspect of 3I Atlas's discovery is the pre-discovery observations. After the official detection on July 1st, astronomers searched through archived images and found that several telescopes had actually photographed the comet as early as June 14th without recognizing it. These early images, captured automatically by survey telescopes, showed 3I Atlas when it was even farther from the Sun and fainter. Finding these pre-discovery observations is valuable because it extends the observational baseline, allowing for more accurate orbital calculations. It also shows how much data we collect without immediately recognizing its significance. The universe is revealing itself to us faster than we can process. More and more, we're finding that the evidence was always there, waiting for us to notice, to connect the dots. Amateur astronomers have contributed significantly to studying 3I Atlas. Sam Dean, an amateur, found additional pre-discovery images in archive data. Observers with backyard telescopes captured images showing the comet's changing appearance over time. This collaboration between professionals and amateurs represents something important about modern science. It's accessible, participatory, collective. You don't need a PhD or a billion-dollar telescope to contribute to understanding the cosmos. You need curiosity, dedication, and access to data. The democratic nature of this science means more eyes watching, more minds thinking, more perspectives contributing. When 3I Atlas brightened enough to be visible in small telescopes, observers around the world saw it, photographed it, shared their data. A global community working together to understand a visitor from beyond. So as we complete the first quarter of our journey, the answer to our title question is becoming clear. Yes, 3I Atlas is changing how we understand space. The old model of solar systems as separate islands is giving way to a new understanding of gentle connection. The new understanding recognizes space as a connected medium through which material regularly flows. Planetary systems exchange material over cosmic timescales. Chemistry, and perhaps even life's building blocks, travel between stars. We're not alone in the sense of being unique. We're not alone in the sense of being isolated either. We're part of a network, participants in galactic processes that have been operating for billions of years. This isn't speculation or theory anymore. It's observed reality. 3 visitors in 8 years have shown us the truth. Connection, not isolation, is the nature of space. Take a deep breath and feel this. Every atom in your body, the carbon, the nitrogen, the oxygen, the iron, was created in the core of a dying star. Just as 3I Atlas carries atoms from another star system, you carry atoms from stars that exploded before our sun was born. We are all made of stardust. We are all travelers through space. We are all connected by the same ancient materials, cycling through the galaxy. Feel yourself as part of this flow, not separate, never separate. Now we continue. The detection of 3 interstellar objects in 8 years allows scientists to estimate the total population. Statistical models suggest there are likely trillions of interstellar objects in our galaxy at any given moment. Most are too small or too far away to detect with current technology. But they're there, drifting between stars, crossing through planetary systems regularly. Within the orbit of Neptune alone, there might be hundreds to thousands of objects the size of Oumuamua or larger right now. We haven't seen them because they're faint and moving against a background of stars. But as our detection capabilities improve, we'll find more and more. The universe is revealing itself to have hidden populations we never suspected, occupying spaces we thought were empty. The time between discoveries is shrinking. Oumuamua in 2017, Borisov in 2019, 3I Atlas in 2025. That's a gap of 2 years, then 6 years. The longer gap doesn't necessarily mean fewer objects. It reflects the time needed to build better detection systems and recognition algorithms. As technology improves, discoveries will accelerate. Scientists predict that within a decade, interstellar object detections could become routine, perhaps even commonplace. What seemed like once-in-a-lifetime events will become regular occurrences. This acceleration in discovery rate mirrors our accelerating understanding. The more we look, the more we find. The more we find, the more patterns emerge. The differences between Oumuamua, Borisov, and 3I Atlas are as informative as their similarities. Different speeds suggest different ejection mechanisms, some gentle, some more energetic. Different compositions suggest formation around stars with different chemistries. Different sizes suggest varying populations of source material. This diversity tells us that interstellar objects don't come from one type of system or one type of process. They represent the full range of planetary system evolution across the galaxy. Every ejection mechanism, every formation environment, every type of star system contributes to the interstellar population. This means sampling interstellar objects gives us a survey of galactic diversity, a census of how planetary systems vary across different regions and epochs of the Milky Way's history. The age of 3I Atlas, 4.6 billion years, represents the kind of timescale over which these exchanges operate. This comet has been wandering for potentially billions of years, slowly crossing the distance between star systems. Such journeys aren't quick. Even at tens of kilometers per second, it takes millions of years to cross light years. But the galaxy has been forming planetary systems for over 10 billion years. There's been plenty of time for this slow exchange to operate. Objects ejected early in the galaxy's history are still wandering today. Objects ejected recently won't reach other star systems for millions of years. It's a patient process, operating on timescales that dwarf human comprehension, but it's constant, ongoing, inevitable. Our solar system isn't just receiving interstellar visitors, it's also sending them. As Jupiter and the other giant planets formed, they scattered countless smaller bodies. Some fell into the sun, some remained in stable orbits, but many were ejected entirely, flung out of the solar system at high speeds to become wanderers themselves. Those objects, ejected from our system billions of years ago, are now out there, crossing through other systems, being detected or not by other observers. If those observers exist, if they've developed astronomy, if they have telescopes, they might be looking at our ejector right now, calling it an interstellar visitor from an unknown system, not realizing it came from here. The processes that send objects into interstellar space operate differently in different systems. Some ejections happen during chaotic early planet formation, when orbits are still settling. Others occur through later gravitational encounters between planets. Still others result from stellar encounters, when another star passes close enough to perturb a system's outer regions. Each mechanism imparts different velocities and trajectories to ejected objects. The fastest objects likely come from the most violent encounters, while slower wanderers might have escaped through gentler processes. Understanding these mechanisms helps us interpret the population of interstellar visitors. Their speeds and trajectories encode stories about how they escaped their home systems, what kinds of violence or gentleness sent them wandering. The thick disk origin of 3I Atlas means it likely formed around a star with lower metallicity than our Sunday. In astronomy, metals means all elements heavier than helium. Older stars formed from gas that had been enriched by fewer supernovae, so they contain fewer heavy elements. If 3I Atlas's parent star was metal-poor, its protoplanetary disk would have had different ratios of elements than our solar nebula did. This could affect everything from the types of minerals present to the abundance of water and organics. Studying 3I Atlas's detailed composition might reveal these differences, giving us a window into planetary formation under different chemical conditions. Each interstellar visitor is potentially a sample from a different chemical regime. Despite coming from another star system, 3I Atlas still obeys the same physical laws as everything in our solar system. Newton's laws of motion and gravity describe its trajectory perfectly. Einstein's relativity isn't needed. Classical mechanics suffices. This universality of physical law is profound. The same equations that predict planetary orbits also predict interstellar trajectories. Physics doesn't care about origin or destination. It just describes motion through space-time, according to universal principles. This means we can understand and predict the behavior of visitors from beyond using the same tools we developed to understand our own system. The laws are truly universal. Understanding local systems gives us understanding of the entire cosmos. Despite the presence of interstellar objects passing through our solar system, the probability of collision with Earth is vanishingly small. Space is vast, and even a densely populated region of interstellar traffic contains mostly emptiness. Objects like 3I Atlas pass through quickly, spending only months within the inner solar system before departing. Their trajectories are generally not aligned with planetary orbits. The chances of a direct hit are astronomical, in the bad sense. This is reassuring but also slightly disappointing. We're unlikely to get a close-up look at an interstellar visitor without mounting a dedicated mission. They pass through too quickly, too far away, to study in the detail we'd like. They're travelers, not residents. The window of opportunity to observe interstellar objects is measured in months, not years. They approach quickly, brighten as they near the sun, then dim as they recede, all within a brief period. 3I Atlas was visible to moderate-sized telescopes for perhaps 6 months total. Before that, too faint. After that, too faint again. This brevity creates urgency. Astronomers must coordinate quickly, prioritize observations, make decisions about how to use limited telescope time. There's no second chance. Once an interstellar visitor fades from view, it's gone forever. This urgency contrasts with observing planets or stars, which are always there, waiting patiently to be studied. Interstellar objects demand attention now or never. Our ability to detect and understand interstellar objects is entirely technology dependent. Without modern digital cameras, automated survey telescopes, and computational power to analyze massive datasets, we'd never spot these faint, fast-moving objects. Without spectrographs and infrared detectors, we couldn't determine their compositions. Without spacecraft positioned throughout the solar system, we'd lack multiple viewing angles. Every aspect of our new understanding of interstellar connections depends on technological capability. This creates a feedback loop. Better technology leads to more discoveries, which motivate investment in even better technology. We're living through a revolution in astronomy, driven by exponentially improving instruments. What's cutting edge today will seem primitive in a decade. Our understanding will continue accelerating. Scientists have proposed dedicated missions to intercept and study interstellar objects up close. The European Space Agency's Comet Interceptor, planned for launch in the late 2020s, will wait at a gravitationally stable point until a suitable target appears, either a pristine Oort cloud comet or potentially an interstellar object. Then it will maneuver quickly to intercept it. Imagine a spacecraft flying alongside an interstellar visitor, studying it from meters away, sampling its dust, analyzing its gases, photographing its nucleus in detail. This would revolutionize our understanding far beyond what distant telescopic observations can achieve. It would make the connection between star systems tangible, physical, undeniable. We would hold in our hands material from another world. The Vera C. Rubin Observatory, now beginning operations in Chile, will transform interstellar object science. With its 8-meter mirror and huge digital camera, it will survey the entire visible sky every few nights, detecting anything that moves or changes. Scientists estimate it could find dozens to hundreds of interstellar objects per year. creating a statistical sample large enough to study population properties. We'll learn about the distribution of sizes, compositions, speeds, and trajectories. We'll identify which types of star systems eject which types of objects. We'll watch the galactic exchange in real time. Within a decade, our understanding will be richer, more nuanced, more complete than we can currently imagine. Every new interstellar object detection allows scientists to refine their models of galactic dynamics and planetary system evolution. How many objects should we detect per year? What should their typical speeds be? What composition ratios should we expect? Each observation either confirms or challenges theoretical predictions, forcing models to improve. 3. IATLAS high speed, for instance, was slightly surprising, suggesting that high-energy ejection events might be more common than initially thought. Borisov's comet, like nature, confirmed predictions about icy body survival in interstellar space. Oumuamua's unusual shape remains puzzling, motivating new theoretical work. Science progresses through this dialogue between observation and theory, each informing the other, both moving toward deeper truth. So here's the second answer emerging. The connection between star systems isn't random or occasional, it's systematic and ongoing. Planetary formation universally involves ejection. Physics universally governs trajectories. Time universally allows for mixing. The result is a galaxy-wide circulation of material that operates constantly, patiently, inevitably. We're not observing rare exceptions. We're observing the tip of a vast iceberg. Most interstellar objects remain undetected, but they're there, crossing through our solar system regularly, connecting us to the broader galaxy. This systematic exchange means our solar system is part of a network, not an island. We participate in galactic processes that redistribute material, chemistry, and potentially even life's building blocks across stellar neighborhoods. Separation was always temporary. Connection is the enduring truth. You're still here, still awake, still drifting with us through these stories. Take a slow breath. Notice how your body feels a little lighter now, as if gravity itself has loosened its grip just slightly. We're traveling through space together, you and I, and everyone listening in the quiet dark, floating through facts like asteroids drifting through the void. There's no rush, no destination, just the gentle momentum of curiosity carrying us forward. Let's continue. If we step back and view the entire galaxy as a single system, interstellar objects become like pollen, seeds, or spores, reproductive material distributed by wind across a landscape. Except this landscape is hundreds of thousands of light years across, and the wind is gravitational dynamics, and the timescales are millions of years. But the principle is similar. Material formed in one location is distributed widely, potentially taking root elsewhere, or at least contributing to the chemical diversity of other locations. The galaxy isn't a collection of separate systems. It's an ecosystem with flows, cycles, and exchanges. We're learning to see these flows for the first time. The theory of panspermia, that life or its precursors might spread between worlds via natural processes, has always seemed speculative. But interstellar objects carrying water, organics, and other prebiotic compounds make it slightly less speculative. Could microbial life survive the journey between star systems, frozen in ice, protected from radiation by meters of rock? Could organic molecules synthesized in one planetary system seed the chemistry of another? We don't know yet, but we know the transportation mechanism exists. Objects do travel between stars. Whether they carry anything beyond chemistry remains an open question, but the possibility is real, not just theoretical. The implications for life's distribution across the galaxy are profound. Each interstellar visitor offers an opportunity for comparative planetology without interstellar travel. Instead of sending probes to other star systems, which would take thousands of years with current technology, we can study samples that come to us. What do different planetary systems look like? How do formation conditions vary? What's common across all systems, and what's unique to each? These questions can be addressed by studying interstellar objects' compositions and comparing them to solar system bodies. Differences reveal the range of planetary environments. Similarities reveal universal processes. We're conducting a survey of galactic planetary diversity, using interstellar objects as free samples delivered to our doorstep. The timescales over which galactic mixing occurs are immense. An object ejected from a star system might wander for millions or billions of years before encountering another system. But the galaxy has been forming planetary systems for over 10 billion years. There's been enough time for thorough mixing in some regions, especially in dense stellar neighborhoods where stars are closer together. Our region of the galactic disk is less dense, so mixing is slower here, but it still happens. Over billions of years, material has been redistributed widely. The atoms in your body might include some that formed in another star system, delivered to our solar nebula via interstellar objects that arrived before Earth formed. We might literally carry pieces of other worlds inside us. Occasionally, stars pass relatively close to each other, not colliding, but passing within a light year or less. These close encounters can perturb the Oort clouds of both systems, sending showers of comets into the inner systems and also ejecting some objects into interstellar space. These encounters are rare for any given star, but common across the galaxy as a whole. Each encounter is a mixing event, exchanging material between systems, redistributing chemistry, connecting stellar neighborhoods. Over billions of years, this process has touched every star system multiple times. We're all connected through this web of encounters and exchanges, even if we've never directly contacted each other. The chemical composition of the galaxy has evolved over time. Early stars formed from nearly pure hydrogen and helium. They fused heavier elements in their cores and scattered those elements through space when they exploded. Later generations of stars formed from gas, enriched by earlier supernovae, creating planets with different chemistries. 3. I Atlas, coming from the thick disk, formed when the galaxy was younger and less chemically enriched. Its composition might reflect that earlier chemical state. By studying interstellar objects from different galactic populations, thick disk, thin disk, halo, we can trace the chemical evolution of the Milky Way. These wanderers preserve information about the galaxy's changing chemistry over billions of years. Our solar system has contributed to the interstellar population, just as others have. Billions of years ago, during the chaotic early period of planet formation, countless objects were ejected. More recently, gravitational interactions with Jupiter continue to eject comets from the Oort cloud. Some of these escape entirely, becoming our contribution to galactic mixing. In a sense, pieces of Earth's original formation environment are now wandering between stars, potentially passing through other planetary systems, being detected or not by other observers. We're not just receivers in this exchange, we're participants, senders as well as recipients. The flow goes both directions, connecting all systems together. Every interstellar object carries information encoded in its physical and chemical properties. Its composition tells where and when it formed. Its trajectory tells about the ejection event that sent it wandering. Its structure tells about its thermal history. Its activity tells about its current response to external conditions. Reading this information is like archaeology, deciphering clues from fragmentary evidence to reconstruct the past. But unlike terrestrial archaeology, which studies human history over thousands of years, Interstellar archaeology studies cosmic history over billions of years. Each visitor is a record, a text written in the language of physics and chemistry. We're learning to read that language more fluently with each discovery. Understanding space as a connected network, rather than isolated islands, requires a shift in thinking. Networks have nodes, star systems, and edges, interstellar trajectories. Material flows through edges, connecting nodes. Properties of the network, density of nodes, frequency of connections, types of material exchanged, determine how information and matter spread. This is network science applied to galactic scales. Our solar system is one node among billions. We're connected to nearby nodes more strongly and to distant nodes more weakly. Understanding our place in this network helps us understand how special or typical we might be. Networks reveal context, relationships, flows. They show the bigger picture. We're halfway through our journey now, and the answer to our question continues to unfold. Could 3I Atlas change how we understand space? It already has. What seemed like empty void between stars is actually filled with travelers. What seemed like isolated systems are actually connected nodes in a galactic network. What seemed like unique, separate worlds are actually parts of a larger ecosystem engaged in constant exchange. The change isn't just in space, it's in us, in how we see ourselves. We're not alone, not isolated, not unique. We're participants in ancient, ongoing processes that connect all planetary systems across the galaxy. This understanding is still settling in, still transforming how we think about our place in the cosmos. Let each breath guide you to realize time is yours, a separate stream that only you are living. While 3I Atlas has traveled for billions of years, while the galaxy turns, while stars are born and die, this second you're breathing, listening, is unique. Your moment of awareness, right now, is as real as anything else in the universe. Cherish the present, not because the past and future don't matter, but because the present is where you are. And we continue drifting. The scale of galactic connection is difficult to grasp. Our solar system is one of hundreds of billions. Each system potentially participates in the exchange. Even if ejection rates are low per system, the total number of interstellar objects is immense. At any moment, trillions of objects are crossing the space between stars. Most are small, faint, undetected, but they exist, carrying material from here to there, connecting everywhere to everything else. This vast scale means you're never truly far from interstellar material. Right now, there might be an interstellar visitor closer to you than the moon, just too small to see. The age of 3I Atlas, 4.6 billion years, is roughly the age of Earth itself. This comet has existed as long as our planet. While Earth cooled, formed oceans, developed life, saw continents shift, species evolve, and eventually produced civilizations, 3I Atlas was wandering in darkness. While our world transformed from molten rock to living biosphere, this ancient ice remained frozen, silent, unchanged. Now they meet briefly. Earth, teeming with life and consciousness. Comet, empty and ancient. Two objects born at roughly the same time, taking completely different paths, finally crossing paths for a moment. Space is silent. No air means no sound waves. 3I Atlas has traveled through perfect silence for billions of years. Its ejection from its home system, however violent, made no sound. Its passage through interstellar space, however swift, makes no sound. Its approach to our sun, its sublimating gases, its streaming tail, all silent. Only light carries news of these events across the void. We receive photons, not sounds. The universe conducts its grandest movements in perfect silence. There's something deeply peaceful in imagining that silence, that profound quiet through which all cosmic processes unfold. The temperature of interstellar space approaches absolute zero, the lowest possible temperature where molecular motion nearly ceases. 3. Atlas spent billions of years in this extreme cold, perhaps just a few degrees above absolute zero. Only briefly, passing near stars, does it warm enough for significant activity. Then back to the deep freeze. This rhythm of dormancy and activity spans millions of years between stellar encounters. The comet sleeps in the cold darkness, wakes briefly near warmth, then sleeps again. A slow rhythm, measured in epochs rather than days, but a rhythm nonetheless. Our solar system receives material from other systems through interstellar objects. Some of this material burns up in our atmosphere as meteors. Some joins our Oort cloud, becoming indistinguishable from native objects. Some passes through without stopping. We're recipients of cosmic mail, deliveries from distant addresses. Each delivery carries information, chemistry, and sometimes perhaps more. We didn't know we were receiving this mail until recently. We couldn't read the return addresses or understand the messages. But now we're learning. We're beginning to recognize the deliveries and appreciate what they bring. Our solar system also sends material outward through ejection. Objects scattered by Jupiter billions of years ago are out there now, crossing through other systems, potentially being detected by other observers. If extraterrestrial civilizations exist and have developed astronomy, they might be studying objects from our solar system right now, wondering about the strange visitors from an unknown system. They might be asking the same questions we are. Where did this come from? What does it tell us? Are we alone? And they wouldn't know. The answer comes from here, from us, from this small blue world. Over billions of years, the distinction between ours and theirs blurs. Material ejected from our system billions of years ago might have passed through other systems, being captured temporarily, then ejected again, traveled further, perhaps eventually returning to our vicinity. Is it still ours? Or has it become theirs? Or something else? The flow is so ancient and complex that identity becomes meaningless. There's just material, wandering, mixing, redistributing. Boundaries dissolve on long timescales. Everything blends into everything else. Separation is temporary. Mixing is inevitable. Every gravitational encounter leaves a trace, a slight change in trajectory. 3I Atlas's path through our solar system will be slightly different going out than coming in, deflected by the sun's gravity. In a sense, our sun leaves a mark on the comet's trajectory, a memory of this encounter, encoded in its motion. The comet carries that memory with it back into interstellar space. Every star it passes will add another small deflection, another memory. Its trajectory is a record of everywhere it's been, every mass it's encountered, written in the language of velocity and direction. 3. Atlas has witnessed galactic history we can only imagine. If it's truly 4.6 billion years old, it formed when the Milky Way looked different. The spiral arms were in different positions. Different stars occupied different locations. The galaxy was younger, more active, more violent. This comet has seen the galaxy evolve over billions of years, watching passively as structures formed and reformed, as stars were born and died around it. It's a witness to cosmic history, though it can't report what it's seen. We must read its testimony in its composition and trajectory. Will 3I Atlas ever return to its home system? Almost certainly not. Its trajectory is taking it in a different direction, deeper into the galaxy. The chances of it encountering the same star system twice are astronomically small. It's a one-way journey for most interstellar objects, ejected from home, never to return. This creates a kind of cosmic diaspora, material spreading outward from origin points, never reuniting. Yet perhaps this is how it should be. Not return, but distribution. Not isolation, but mixing. The galaxy becomes richer through this spreading, this sharing of material across vast distances. In its billions of years of wandering, 3I Atlas has likely passed near other stars before reaching ours. Each encounter was brief, a few months within any given system, then back to the darkness. How many systems has it visited? Dozens? Hundreds? We don't know. Each encounter was a chance for observation, though probably no one was watching. Most stars don't have civilizations, don't have telescopes, don't have observers to notice the passing visitor. Most encounters go unwitnessed, undocumented, unremembered. We're fortunate to be here, now, able to see and understand what this ancient wanderer represents. Mathematically, the mixing of interstellar material can be modeled using diffusion equations, similar to how heat or chemicals spread through a medium. The galaxy acts as a medium, and interstellar objects act as particles diffusing through it. On timescales of billions of years, significant mixing occurs, especially within local neighborhoods of stars. The math shows that material spreads predictably, following statistical patterns. What seems chaotic on individual levels becomes ordered when viewed statistically. The galaxy has structure, patterns, predictable behaviors. Understanding these patterns helps us predict what we'll find as detection rates increase. Our Sun resides within the local bubble, a region of low-density hot gas created by supernova explosions over the past 15 million years. This bubble affects how interstellar material moves through our neighborhood. Objects passing through the bubble might encounter different radiation environments, different gas densities, different dust distributions than objects traveling through denser regions. Our local environment within the galaxy is unique in some ways, typical in others. Understanding this context helps us understand whether the interstellar objects we detect are representative of the galaxy as a whole or biased by our particular location. In the future, we'll detect more interstellar objects, each with its own story. Some will be large and active like 3I Atlas. Others will be small and inert. Some will be fast, others slow. Each will add to our understanding, refining our models, answering some questions while raising new ones. The science of interstellar objects is just beginning. In 100 years, we'll have observed thousands. In 1,000 years, perhaps we'll have sent probes to study them up close. The field is young, the discoveries are coming fast, and our understanding is evolving rapidly. As more interstellar objects are discovered, citizen science opportunities will expand. Amateur astronomers can contribute observations, help track objects, process data, identify anomalies. Anyone with a telescope and camera can participate. The democratization of astronomy means more eyes watching the sky, more chances for discovery, more diverse perspectives contributing to understanding. Science benefits from this broad participation, from the collective effort of professionals and amateurs working together. The cosmos belongs to everyone, and everyone can contribute to understanding it. Curiosity and dedication matter more than credentials. Beyond the scientific implications, interstellar objects create a philosophical shift. They make the abstract concept of other star systems concrete. These aren't just points of light in telescopes. They're real places that produce real objects we can study. This tangibility changes how we think about the galaxy. It's not theoretical or distant. It's here, touchable through the light reflected from interstellar visitors. This shift from abstract to concrete is profound. Other star systems become real in a new way. The galaxy becomes a neighborhood rather than a gallery of distant lights. Connection becomes experiential, not just intellectual. If we think of interstellar object exchange as a form of communication, it's the slowest conversation imaginable. Messages take millions of years to deliver. Responses take millions of years to return. Yet it's a real exchange. Material moving between systems. Information encoded in that material, waiting to be read. We're just learning to understand the messages, to decode the information carried by these ancient travelers. It's a one-sided conversation so far. We receive, but haven't yet consciously sent. But perhaps someday we'll learn to send our own messages, encoded in objects we deliberately eject toward other stars. Studying 3, I-Atlas teaches humility. This object is older than our civilization, older than our species, older than complex life on Earth. It's witnessed cosmic history we can barely imagine, yet it's a small, simple thing. Ice and rock, nothing more. No intelligence, no awareness, just matter obeying physical laws. If such a simple thing can be so ancient, so traveled, so connected to the vastness of space and time, what does that say about us? We're newer, younger, more limited than we sometimes admit. The cosmos operates on scales that dwarf human concerns. What seems chaotic on individual scales, the ejection and wandering of trillions of objects, becomes pattern on larger scales. Statistical patterns emerge, distributions of speeds, sizes, compositions. The chaos of individual trajectories averages out into predictable flows. This is a general principle. Complexity at small scales often produces simplicity at large scales. Individual molecules move chaotically, but temperature is a smooth property. Individual people make unpredictable choices, but populations follow statistical patterns. Individual interstellar objects wander randomly, but the population flows like a fluid. Understanding requires choosing the right scale to observe. Studying interstellar objects is a form of cosmic archaeology. We're excavating information about the past from physical artifacts, just as archaeologists do with ancient human civilizations. Except our artifacts are billions of years old, from civilizations of matter rather than intelligence. Each object is a relic from a distant time and place, carrying information about formation conditions, chemical environments, thermal histories. By collecting and studying many such relics, we reconstruct the history of planetary formation across the galaxy. We're archaeologists of the cosmos, piecing together galactic history from the fragments that wander through our neighborhood. We're living through a transition period in human understanding. Our grandparents' generation didn't know interstellar objects existed. Our generation is discovering they're common. Future generations will take their existence for granted. We'll grow up with regular detections as normal. This transition is a privilege, a chance to witness discovery, to feel the shift from old model to new understanding. We're the bridge generation, connecting past ignorance with future knowledge. Living through such transitions is rare. Most people live in stable understanding. We're lucky to live when the sky itself is revealing new truths. The existence of regular interstellar traffic has implications for the search for extraterrestrial intelligence. If civilizations exist elsewhere, they might use interstellar objects as probes, either by sending artificial ones or by catching and studying natural ones, as we're learning to do. Extremely advanced civilizations might even modify interstellar objects to carry messages or technology. While 3I Atlas shows no signs of being artificial, future visitors might. The intersection of SETI and interstellar object studies is just beginning. What seems like simple space rocks today might someday reveal themselves as something more. or at least point the way toward detection of artificial visitors. Interstellar objects are becoming normalized in astronomy. What was science fiction a decade ago is now mainstream science. Textbooks are being rewritten. Courses are being updated. The next generation of astronomers will grow up with interstellar visitors as part of the standard model, not exotic exceptions. This normalization is healthy, reflecting accurate understanding rather than outdated assumptions. But it also risks losing wonder. As detections become common, will we still feel amazed? Or will interstellar objects become routine, unremarkable, just another category of celestial body? Perhaps both, understood yet still wondered at, familiar yet still profound. Perhaps the deepest lesson from 3I Atlas is that connection, not isolation, is fundamental to cosmic reality. At every scale, atomic, molecular, planetary, stellar, galactic, systems exchange material and information. Nothing is truly isolated. Everything participates in larger flows, larger cycles, larger systems. The universe is fundamentally relational, not compositional. It's not made of separate things, but of things in relationship, things connected through various forces and exchanges. Interstellar objects are just one example of this universal connectivity. They make the abstract principle concrete, visible, measurable. They show that even across the vastest voids, connection persists, material flows, relationships exist. So here's the third answer. Our solar system isn't separate from the galaxy. It's an integrated part of a galactic network. We receive material from other systems. We send material to other systems. We're participants in flows that redistribute chemistry across stellar neighborhoods. This isn't speculation. It's observed fact, demonstrated by 3 interstellar visitors and counting. The question, are we alone, has multiple answers. We're alone if we mean intelligent life? Maybe. But we're not alone if we mean connected, participating, part of larger systems. We belong to the galaxy in a literal, physical sense. We always have. We're just now seeing clearly. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. 3I Atlas orbits the galactic center. The galactic center orbits what? Perhaps other galaxies in the local group. Everything moves in cycles, within cycles. Like your breath. Inhale, exhale, inhale, exhale. A small cycle within the vast universe. You are also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order, like comets silently rotating through space, unhurried, unresisting, simply existing. We're almost there now. For billions of years, interstellar objects cross through our solar system unobserved. No eyes to see them, no minds to understand them, no tools to detect them. Then, in the last few million years, intelligence evolved on one small planet, and in the last century, that intelligence developed technology capable of detection. Now we watch, now we see, now we understand. The universe didn't change, we changed. We awakened to what was always there. The traffic was always flowing. We just didn't notice until now. The atoms in 3I Atlas don't know they came from another star system. They don't remember their origin. They just exist, bound by molecular forces, responding to heat and cold, following physical laws. They don't care about significance or meaning, yet we care. We're the ones who assign meaning, who find wonder in origin stories, who see connections across space and time. Meaning isn't in the atoms themselves, but in the minds that contemplate them. Consciousness creates meaning from meaningless matter. Looking at 3I Atlas changes how we see our own world. Earth becomes one planet among countless billions. Our sun becomes one star among countless billions. Our atoms become recycled stardust, no different from the atoms in interstellar comets. This perspective doesn't diminish us, it situates us. We're part of something vast, ancient, ongoing, not separate, not special, but connected, belonging, participating. This shift from isolated uniqueness to connected participation is profound, even liberating. Space isn't empty fabric waiting to be filled. It's already full of fields, particles, light, interstellar objects, gravitational influence. Everything touches everything else through these subtle connections. You're connected to 3I Atlas right now through the gravitational field we share. Though the force is vanishingly small, you're connected through the photons that bounced off it, traveled across space, and entered telescopes on Earth. Connection isn't metaphor. It's literal, physical, measurable. On time scales of billions of years, the distinction between our system and their system dissolves. Material mixes so thoroughly that identity becomes meaningless. In the distant future, atoms from Earth might be scattered across the galaxy in interstellar objects. Atoms from distant systems might become part of planets, part of life, part of minds, thinking about the cosmos. Boundaries are temporary. Given enough time, everything becomes part of everything else. The universe is fundamentally united, only temporarily separated. 3I Atlas was always there, moving through space according to laws that never changed. But we couldn't see it until we learned how. We had to invent telescopes, develop digital cameras, write algorithms, build networks of observers. Seeing isn't passive, it's active, learned, technological. The universe reveals itself only to those who develop the tools and skills to look properly. What else is out there, invisible to us, simply because we haven't yet learned the right way to look? Astronomy teaches patience. Interstellar objects take billions of years to travel between stars. Light takes years to cross interstellar distances. Civilizations, if they exist, would take decades or centuries to communicate with. Everything operates on timescales that dwarf human lifespans. Yet we're learning to think on these scales, to appreciate these slow rhythms. This patience is a gift, training us to think beyond immediate concerns, beyond individual lifetimes, connecting us to deeper time. 3I Atlas has traveled in absolute silence and solitude for eons. No companion, no witness, no external validation of its existence. It simply was and is and will continue to be, regardless of observers. There's something profound in this indifference. The universe doesn't need our attention to be real. Things exist independent of perception. This fact is both humbling, we're not necessary, and liberating. Reality isn't dependent on us. We share fundamental kinship with 3I Atlas, both formed from the same kinds of atoms, forged in stellar furnaces, both subject to the same physical laws, both temporary arrangements of matter, briefly organized into patterns before eventually dissolving. This kinship isn't sentimental or metaphorical, it's literal. We're made of the same stuff, following the same rules, participating in the same cosmic story, distant relatives, briefly aware of each other across the vastness. Even as we understand more, wonder doesn't diminish. Knowing that 3I Atlas is 4.6 billion years old doesn't make it less amazing, it makes it more amazing. Understanding its trajectory doesn't reduce wonder, it deepens it. Science doesn't kill mystery, it reveals deeper mysteries. Each answer opens new questions. Each discovery shows more to discover. Wonder grows with understanding, not shrinks. The cosmos is endlessly fascinating, endlessly surprising, endlessly worthy of attention and awe. So, could 3I Atlas change how we understand space? Yes, absolutely, completely. Space is not empty void separating isolated systems. It's connected medium linking, participating nodes. Isolation was always illusion, born of limited vision. We couldn't see the connections, so we assumed they didn't exist. But they did, and do, and always have. 3 interstellar visitors in 8 years have shown us the truth. Connection is fundamental. We're part of the network. We always were. But the change is more than space. It's us. It's how we see ourselves. Not as alone, not as separate, not as unique and isolated on our pale blue dot, but as participants in galactic processes, recipients and senders of material, part of flows and cycles and exchanges that connect all systems across vast distances and timescales. This transformation in self-understanding might be more important than the transformation in understanding space itself. 3I Atlas is an invitation, not from anyone, just from the universe itself. An invitation to see more clearly, think more broadly, understand more deeply. An invitation to recognize connection where we assumed separation. An invitation to feel kinship with the cosmos, to know ourselves as part of something ancient and vast and ongoing. The invitation has always been there, but we're only now learning to read it, to accept it, to respond. When the next interstellar visitor arrives, we'll be more prepared. Better telescopes, better algorithms, better understanding. We'll greet it not as anomaly, but as expected guest. We're learning the patterns, anticipating the arrivals, understanding the traffic. Each visitor will be welcomed, studied, appreciated. We're becoming hosts in our small corner of the galaxy, ready to receive whatever the cosmos sends, ready to learn from whatever arrives, ready to embrace the gifts of connection. Interstellar objects are both ordinary and miraculous. Ordinary because they're common, natural, predictable. Miraculous because they cross impossible distances, carrying ancient chemistry, connecting distant worlds. This combination, ordinary miracle, characterizes much of the cosmos. Stars are ordinary, yet each is a furnace fusing elements. Planets are common, yet each is a unique world. Life might be widespread, yet remains precious. The universe is full of ordinary miracles. 3I Atlas is one more example. There's something in 3I Atlas's journey that speaks to letting go, ejected from home, never to return. Wandering without destination, without purpose, just following physical laws wherever they lead. No resistance, no grasping, no attachment. Simply moving, being, existing in whatever moment is present. Perhaps there's wisdom in this, a model for living, not clinging to what was, not anxious about what will be, just being in what is. Everything flows. Material flows between stars. Energy flows through space. Time flows forward. Information flows through consciousness. The universe is not static, but fluid, always moving, always changing, always transforming. 3I Atlas embodies this flow. It is flow, material in motion, participating in the universal circulation of matter and energy. We too are flow, not fixed things but processes, patterns in flux, temporarily stable before dissolving back into the general flow. The universe doesn't struggle against itself. Gravity pulls, orbits curve, objects move according to their velocities and masses. No resistance, no complaints, just physical law unfolding. There's a kind of acceptance in this, a teaching about working with rather than against. 3I Atlas doesn't fight its trajectory. It follows where momentum and gravity lead. Perhaps consciousness is the universe's capacity to resist its own nature. Or perhaps, at our best, we embody the same acceptance. Most of 3I Atlas's existence is spent in darkness between stars, dormant, frozen, silent. Only briefly, near stellar warmth, does it wake into activity, then back to darkness. This rhythm, most time resting, brief activity, might be universal. Stars spend most of their lives in stable burning, brief, dramatic beginnings and endings. Civilizations, if they exist, likely spend most time quietly developing, brief periods of expansion or discovery. Darkness and rest aren't absence. They're the default, the natural state. 3I Atlas has no destination. It's not trying to reach anywhere. It's not failing by not arriving. It's simply moving, being wherever it is, until it's somewhere else. There's no purpose to fulfill, no goal to achieve, no endpoint to reach, just existence, in motion, without needing justification beyond existing. Perhaps the universe itself is like this. No ultimate purpose, no final destination, just being, unfolding, existing in its own way. Here's a thought. Consciousness is the universe waking up to itself. For billions of years, matter simply was, existing without awareness, moving without knowing. Then, on at least one planet, matter organized itself into forms capable of awareness. Now the universe can look at itself through our eyes, think about itself through our minds, feel wonder at itself through our emotions. We are the cosmos, becoming conscious of its own existence. There's something worth acknowledging. Gratitude. Gratitude that we exist in a time when interstellar visitors are being discovered. Gratitude that humans developed astronomy and physics and technology. Gratitude that 3I Atlas's path happened to cross ours. Gratitude that consciousness exists to contemplate these things. Gratitude isn't directed at anyone or anything. It's just the appropriate response to existence itself, to being here, to having this moment of awareness and understanding. 3I Atlas's story isn't ending. It's continuing, fading from our view, but still existing, still moving, still being. Our chapter with it closes, but its chapter continues. And our story continues too, watching for the next visitor, building better telescopes, deepening understanding. Stories don't end, they just move beyond our view. The universe keeps going, keeps unfolding, keeps generating new chapters. We're privileged to read a few pages of this endless book. Understanding our place in the cosmos brings a certain peace, not because we're important, we're not, particularly, but because we're part of it, connected to it, belonging to it. The anxieties that dominate human consciousness, status, success, security, seem smaller from cosmic perspective. Not unimportant, but rightfully sized. We're participants in something so vast, so ancient, that our individual concerns become lighter, more bearable. Perspective is a gift. The final answer to could 3I Atlas change how we understand space is this. It changes more than space. It changes us. It reveals that we've never been isolated, never been separate, never been alone in the way we feared. We're threads in a vast web, participants in ancient cycles, recipients of gifts from distant stars. Understanding this doesn't solve problems or answer all questions, but it offers something valuable: perspective, connection, belonging. The universe, through this ancient visitor, reminds us we're home. And so, our quiet journey through the story of 3I Atlas comes to a gentle close. We've traveled from old assumptions about isolation and separation to new evidence of connection and exchange, discovering along the way that this visitor from beyond teaches us not just about space, but about ourselves. From the discovery of an ancient wanderer to the revelation of galactic networks, from questions about uniqueness to acceptance of participation, we've glimpsed how one small object rewrites the story of space itself. 3I Atlas reminds us that connection, not isolation, is the fundamental nature of reality. Much of the universe's most profound work happens silently, in the darkness between stars, in the slow, patient drift of ancient ice across light years. These visitors teach us that boundaries are temporary, that separation is illusion, that we belong to something vast and ancient. By pausing to notice, we glimpse our place in the cosmic web. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about unity of every atom, every event, every moment in the universe. You are not separate. You are a link in the endless chain. Like 3I Atlas, you're made of stardust, temporarily arranged into a form that can look up and wonder. Soon, that form will dissolve back into the general flow, atoms returning to circulation. Let your entire being dissolve into that truth now, into the gentle darkness, into the soft acceptance that everything is connected, everything flows. Prepare for deep sleep, no boundaries left, only peace, only belonging, only home. If this gentle journey through the cosmos brought you peace tonight, perhaps share it softly with someone else who's searching for stillness under the stars. It might be exactly what another restless mind needs to finally let go and drift. One quiet share, one peaceful night at a time. But there's no need to do anything now, nothing at all. You've traveled far tonight, not through space, but through understanding. You can allow these thoughts of ancient comets and cosmic connections to fade now, like stars at dawn, leaving only the peaceful knowing that you belong. Let your breathing deepen. Let your body feel heavier, as if Earth itself is pulling you gently down into safety, into rest. If sleep comes, let it carry you like 3I Atlas drifting through space, smoothly, inevitably, without resistance, into a realm where boundaries dissolve and everything flows together. If your eyes are still open, the next video is waiting. But if they're closed, stay there. Stay in the darkness that feels like home. Tomorrow, 3I Atlas will still be moving through space, carrying its ancient message. The network will still be operating, material still flowing between stars. But tonight belongs to stillness, to rest, to the peace of knowing you're part of something vast and connected. Rest well, cosmic traveler, and remember, you were never alone. You never could be. Everything is connected, including you. Dream deeper with Bedtime Science. Good night.